Hi students, in today's class we are going to see chapter 1 of the applied mathematics, fourth concept, pipes and cistern. In this session we are going to fill through pipe A and pipe B. Individually, if they are going to fill the tank in X hours for pipe A and if pipe B is going to fill the tank in Y hour, then if both the pipes are opened at the same time, then how much time it will take to fill the tank? In that case, part of the tank filled by pipe A in 1 hour will be equal to 1 by X, because pipe A takes X hours to fill the tank. Suppose if the pipe A takes 5 hours to fill the tank, in the first hour it will fill 1/5 of the tank. In the next hour it will fill another 1/5 of the tank. Next 1 hour it will take another 1/5 of the tank, and in next 1 hour it will take another 1/5. Finally, in the last hour it will try to fill the entire tank individually. Suppose pipe B takes 10 hours to fill the tank. What will happen? In the first hour it will fill only 1/10 of the tank. If you divide the entire tank into 10 equal parts, then in the first hour it will try to fill the first 1/10 of the tank. Next hour it will take another 1/10 and it will go on, and in the last hour it will try to fill the entire tank. Now the question is, if both the pipes are open together, how much time will it take to fill the entire tank? That type of question we are going to see in this session. And a part of the tank filled by pipe B in 1 hour will be equal to 1 by Y. If both the pipes are open together, then part of the tank filled in 1 hour will be 1 by X plus 1 by Y. When you take LCM, you will get Y plus X divided by XY. So in 1 hour, Y plus X by XY part of the tank will be filled. So number of hours required will be equal to XY divided by X plus Y. Similarly, now we have a situation in which the tank is filled by 3 pipes: pipe A, pipe B, pipe C. Pipe A takes X hours to fill the tank individually, and pipe B takes Y hours to fill the tank, and pipe C takes Z hours to fill the tank individually. Now if all the 3 pipes are open together to fill the tank, how much time it will take. So tank is filled by pipe A in x hours. It is filled by pipe B in y hours. Filled by third pipe, pipe C in z hours. So part of the tank filled by pipe A in 1 hour is part of the tank filled by tap or pipe A is equal to 1 by x hours. Part of the tank filled by pipe B will be equal to 1 by, now part of the tank filled by pipe A is 1 by x, part of the tank, because it takes x hours to fill the entire tank. So in 1 hour it will fill 1 by x part of the tank, and part of the tank filled by pipe B will be 1 by y, and the tank is filled by pipe C individually in z hours. So what will be the part of the tank which will be filled by the third pipe z in 1 hour? Part of the tank filled by pipe C in 1 hour will be 1 by z. If all the three pipes are opened together at the same time, then part of the tank filled in 1 hour will be equal to 1 by x plus 1 by y plus 1 by z. We have to sum it up everything. So in that case we take LCM for the calculation purpose. So x, y, z, and when you take LCM, we have the LCM as x, y, z, but here we are having x. So when you take LCM, we have to multiply the numerator with y, z. For the second term, y in the denominator, so multiply with x, z. For the last term, it will be x, y. So time required will be, we have to take the reciprocal. xy z divided by xy plus yz plus zx. So in this case, both the pipes are open together to fill the tank. Okay. Now we have the next concept. Now we have a case in which we are having two tap. One is tap A, which will fill the tank in x hours, and we have another tap which try to empty, which is going to remove the water from the tank in y hours. This is tap B, which is used to, this is tap B, which is used to eliminate the water from the tap, and it takes the time y hours. Now we are having two cases. Case 1, time taken by the pipe A to fill the tank, that is X, is greater than time taken by the pipe B to empty the tank, that is Y. That is, X takes more time than Y. In this case, what will happen? The rate of flow of water inside the tank is slow, and the rate of eliminating the water or removing the water from the tank is more, because the pipe B empties the tank faster than the tank is filled inside. Now, part of the tank filled by pipe A in 1 hour will be equal to 1 by X part. So, part of the tank filled by part of the tank emptied by pipe B in 1 hour will be equal to 1 by Y. Okay. Since X is greater than 1, Y, 1 by X will be less than 1 by Y. So, time taken for emptying the tank only we are going to calculate. Time taken. Okay. Now, we are going to calculate part of the tank emptied in 1 hour will be equal to 1 by Y minus 1 by X, which is nothing but X minus Y divided by XY. So, time taken to empty the tank will be equal to XY divided by X minus Y. So, in this case, tap A takes more time to fill the tank than tap B, which eliminates the water or the liquid. Okay. Pipe B eliminates the liquid faster. Okay. Whereas tap A takes more time to fill it up, but tap B eliminates in the faster rate than tap A. In such case, the outflow is faster, inflow is slower, so the tank will be emptied naturally. So, the time taken to empty the tank will be equal to XY divided by X minus Y. Now, we are having the same scenario, the tank A, now we are having the same scenario, we are having a tank in which tap A fills the tank and it fills the tank in X hours, and pipe B empties the tank in Y hours. Now, Y is going to be greater than X. That is, the time taken for the pipe B to empty the tank is greater than the time taken by the tap or pipe A to fill the tank. Okay. pipe A fills the tank in X hours. Pipe B empties the tank in Y hours. Now pipe B takes more time. So Y is greater than X. In this case, part of the tank filled by pipe A is equal to 1 by X part. Part of the tank filled by part of the tank emptied by pipe B is 1 by Y. Now we have Y is greater than X. So 1 by Y will be less than 1 by X. Okay. So part of the tank filled in 1 hour will be 1 by X minus 1 by Y, which is nothing but Y minus X divided by XY. So time taken to fill the tank will be equal to XY divided by Y minus X. We have to take the reciprocal. And in this session, we are going to see problems of this type only. Okay. With this, we go into the first problem. Here we are having the problem. Two pipes A and B which can fill the tank in 24 minutes and 36 minutes respectively. If both the pipes are open together, then find the time in which the tank will be filled completely. So here we are having two pipes. One pipe is A which fill the tank in 24 minutes, and we have another pipe B which fill the tank in 36 minutes individually. Now both the pipes are open at the same time to fill the tank. Now we are supposed to find the time taken to fill the entire tank. So we have the pipe A takes 24 minutes to fill the tank. Pipe B takes 36 minutes to fill the tank. So they are given the time in minutes. So we are going to do the calculation also in minutes only. So part of the tank filled by pipe A in 1 minute is equal to, here we are having the scenario, okay, the tank is filled by pipe A in 24 minutes. So in 1 minute it will fill 1 by 24 part of the tank. So part of the tank filled by pipe B in 1 minute will be 1 by 36 part. So part of the tank filled by both pipe A and pipe B in 1 minute will be equal to 1 by 24 plus 1 by 36. We are adding. Why? Because both the pipes are opened together. So we have to add this fraction. So we are going to take LCM for 24 and 36. LCM will be 72. Okay. In 72, 24 will go 3 times. So we multiply both the numerator and denominator by 3. So we get 3 here plus 1 by 36. Okay. In 72, 36 will go 2 times. So this is 2. So when you add, it is 5 by 72. So this is the part of the tank which is filled by both pipe A and pipe B in 1 minute. So time taken to fill the entire tank will be (72 by 5), which is equal to, we divide 72 by 5. 4.4 minutes, and we are having 0.4 minutes. That 0.4 minutes will be converted to seconds. So 0.4 into 60. So the final answer is 14 minutes 24 seconds. So the same problem also can be done in using the formula. Okay. When pipe A takes 24 minutes to fill the tank, it will be taken as X. And second pipe will be taken as Y. Then time taken to fill the tank is given by the formula. If it is open together, it is given by the formula xy divided by x plus y. Xy divided by x plus y. So which is nothing but 24 into 36 divided by 24 plus 36, which is equal to 24 into 36 divided by 60. So we divide 6 6 are 36. This is 10. We divide this one by 2. 12 2s are 24. This is 5. So this is 72 by 5, which is equal to 14.4 minutes. And we know how to convert this 0.4 minutes to seconds. We multiplied 0.4 with 60. Why we are supposed to multiply with 60? Because 1 minute is equal to 60 seconds. So 0.4 minute will be equal to 0.4 into 60. It is 24 seconds. So it is 14 minutes 24 seconds. So if the pipe A takes 24 minutes and the pipe B takes 36 minutes to fill the tank individually, if both the pipes are used to fill the tank at the same time, then the tank will be filled by 14 minutes and 24 seconds. Now we have another question. Here, a pipe can fill a tank in 20 minutes and another pipe can empty the same tank in 60 minutes. If both the pipes are open together, then find how much time will they take to fill the tank. Why it is going to fill the tank? Because filling up the tank is 20 minutes only. So it is filled in faster rate. Okay. Because the rate is faster, the time consumed is lesser. And the second pipe is going to empty only in 60 minutes. Okay. Rate of inflow is more, outflow is less. So we are having a chance to fill the tank only. Okay. So we are going to solve this problem now. So we start with the solution. Pipe fill the tank in 20 minutes. We take x is equal to 20. Another pipe empty the tank in 60 minutes. We take y is equal to 60. Now, in 1 minute, because the questions are given in minutes, we try to solve with minutes. Now, part of the tank filled by the pipe in 1 minute. So it takes 20 minutes to fill the tank. So in 1 minute it will fill 1 by 20 part. Part of the tank emptied by another pipe in 1 minute is equal to 1 by 60 part. Now it is going to be filled in. So part of the pipe filled in 1 minute when both the pipes are operated together will be 1 by 20 minus 1 by 60. That is equal to, because both are in fraction, we try to take LCM. So it is 60. We take 3 minus 1, that is equal to 2 by 60, which is equal to 1 by 30 part. So in 1 minute, 1 by 30 part of the tank will be filled in. So time taken to fill the entire tank will be time taken to fill the entire tank What we are supposed to do now? We have to take the reciprocal. So which is equal to 30 minutes. No, the same problem also can be done in formula method. We are given with x is equal to 20 and y is equal to 60, and this is going to fill the tank and this is going to empty the tank. All are going to be in minutes, and here we are having y is greater than x. So time taken to fill the tank is equal to x into y divided by y is greater, correct? So it is y minus x, that is 20 into 60 divided by 60 minus 20. If you use this formula, this is 60 into 20 divided by 40. So we cancel 0 here. So 2, 2s are 4, 1 2s are 2. We cancel 2 again. So it is 30. So the final answer is 30 minutes. So if the first pipe is going to fill the tank in 20 minutes and the second pipe is to empty the tank in 60 minutes, if both are operated together, then it will take 30 minutes to fill the tank. Now we have another problem. A pipe can fill the tank in 40 minutes. Okay. In the tank, there is a leakage at the bottom. Leakage is going to happen at the bottom. Okay. Because of the leakage, it took 60 minutes to fill the tank. Okay. How much time will it take for the leakage to empty the full tank? Tank is filled with water. Now the tap is switched off. Okay, we are not going to pour any water inside. The tank is full. Now we are supposed to find the time by which the tank will be emptied due to leakage. Okay, we start the problem. We start the solution. We try to understand the question. Pipe is going to fill the tank in 40 minutes. Pipe fill the tank in 40 minutes. So we take x is equal to 40. And we don't know how much time it will take for the leakage to empty the tank. So we will try to write leakage in the bottom of the tank empty the tank in y minutes. Is it clear? We are supposed to find the value for y. So we start. Part of the tank filled by pipe in 1 minute will be equal to 1 by 40 part. Part of the tank emptied by leakage in 1 minute will be equal to 1 by y part. Now both are going to happen simultaneously. So part of the tank filled in 1 minute will be 1/40 minus 1/y. Okay. Now in the question they have given together with the pipe as well as leakage, it is going to be filled, the tank is going to be filled in 60 minutes. Is it clear? So we try to simplify this one. When you take LCM, the LCM will be 40y, this one will be y minus 40. Is it clear? So time taken to fill the tank with the leakage will be the reciprocal of this expression, that is 40y divided by y minus 40, and it is given to us equal to 60 minutes. This value is provided in the question. So we take LCM, we cross multiply this expression, 40y is equal to 60 into y minus 40. So we try to simplify this expression. We can cancel 0 on either side. This is 3 times 2, this is 2. So 2y is equal to, we multiply with 3 inside, 3y minus 3 into 40, it is 120. Okay. So 2y minus 3y is equal to minus 120. So minus y is equal to minus 120, which implies y is equal to 120 minutes. 120 minutes is nothing but 2 hours. If the tank is full and pipe is not going to be used to fill the tank, then the leakage alone will make the tank empty in 2 hours. So this is the answer we found out. Now we are having another question. A pump can fill a tank with water in 2 hours. Because of a leakage, it took 1/3 half an hour to fill the tank. How much time will it take for the leakage to drain all the water of the full tank? It is similar to the previous problem. So we are having a tank. A pump is going to fill the tank. Okay, the time taken for this pump to fill the water is going to be 2 hours, and there is a leakage. There is some leakage, minor leakage in this bottom. Okay, because of that the water is going to leak from the tank. Okay, so instead of 2 hours, instead of 2 hours, it is going to be 2 1 by 3 hour. What is 2 1 by 3 hour? 2 hours we know. What is that 1 by 3? 1 by 3 part of hour. That is 1 by 3 into 60. That is 20. So it is going to take 20 minutes extra. 2 hours, 20 minutes. Is it clear? Now our question is, how much time will it take for the leakage to drain the water from the full tank? It is going to be a full tank. Only by the leakage, the time taken to empty the tank we are supposed to calculate. So we are going to do the problem as we did in the previous problem. Solution. Time taken to fill the tank is 2 hours. So we take x is equal to 2. Time taken for the leakage to empty the tank. We don't know, that's what we are supposed to find. It is going to be y hours. So everything is given in hours. So we try to use hour itself. Okay. We need not convert to minutes. So we do it with hours. Part of the tank filled by pump in 1 hour, because it takes 2 hours to fill the tank. So 1 hour it will fill 1 by 2 part. Part of the tank emptied by leakage. In 1 hour. We assumed it takes y hours to empty. So in 1 hour it will empty 1 by y part of the tank. Now we are going to calculate the part of the tank filled together. Filled in 1 hour will be equal to 1 by 2 minus 1 by y. So we try to take LCM, which is nothing but y minus 2 divided by 2y. So in 1 hour, y minus 2 divided by 2y part of the tank will be filled. Therefore, time taken to fill the tank is equal to, we have to take the reciprocal. It is 2y divided by y minus 2. And it is given by 2 1 by 3 hours. Okay. 2 1 by 3 r. So we try to simplify this expression. 2y divided by y minus 2 is equal to, this is 7 by 3. So we try to cross multiply. When you cross multiply, it is 3 into 2y is equal to 7 into y minus 2. So 6y is equal to 7y minus 14. So we bring y term to the left hand side. 6y minus 7y is equal to minus 14. So minus y is equal to minus 14r. So minus cancel. So y is equal to 14 hours. So if the tank is filled by the pump in 2 hours and the leakage, due to leakage, if it is going to take 1/3 of an hour extra, then the leakage will drain the entire tank in 14 hours. So this is the final answer. Now, we are having another problem. We are having a situation in which the tank is going to be filled in by 2 pipes. Pipe A. Now we are having another problem. 2 pipes A and B running together. It filled the tank in 6 minutes. Okay. And if pipe A takes 5 minutes less than to fill the tank than pipe B. Suppose pipe B takes 10 minutes to fill the tank, then pipe A will take only 5 minutes. Suppose pipe B takes 25 minutes to fill the tank, then pipe A will take 5 minutes less, that is 20 minutes to fill the tank. Okay, but we are going to find the time taken by pipe B to fill the tank alone. Is it clear? So we start. Time taken for pipe A to fill the tank is, we take it as x minutes, because the answer is in minutes, we take in minutes, x minutes. Okay, then what will be the time taken by pipe B to fill the tank? Time taken for pipe B to fill the tank will be x plus 5 minutes. So we are going to find the solution now. So how we start the problem? We are going to find the time taken by the pipe B. So we start with the pipe B. time taken to fill the tank by pipe B alone. Okay, whatever we calculate is only for separate thing. Pipe B alone will be x minutes. We take it as x minutes. Now what will be the time taken to fill the tank by pipe A? What is the time taken for the pipe A to fill the tank? The relation is given in the question itself. Pipe A takes 5 minutes less than pipe B. So we take this as x minus 5 minutes. So part of the tank filled by pipe B in 1 minute is equal to 1 by x. Part of the tank filled by pipe A in 1 minute will be 1 by x minus 5 part. Is it clear? Now both the pipes are operated together, then part of the tank filled in 1 minute by both the pipes is equal to 1 by x plus 1 by x minus 5. We try to take LCM. It is x into x minus 5. So by cross multiplication rule, it will be x minus 5 plus x. So it is 2x minus 5 divided by x square minus 5x. So this is the part of the tank which is filled by the pipes A and B when it is operated together. Okay. So time taken to fill the tank will be equal to x square minus 5x divided by 2x minus 5, reciprocal of this expression. Okay, and it is given to us as 6 minutes. This implies x square minus x square minus 5x is equal to 6 into 2x minus 5. So we try to simplify this further. X square minus 5x is equal to 6 into 2, 12x minus 30. So we bring all the term together, it is x square minus 5x minus 12x plus 30 is equal to 0, which is equal to x square minus 17x plus 30 is equal to 0. So we factorize. When we multiply, we should get 30. Okay, it is plus 30. So on addition, we should get 17. So the factors are 15 and 2. And here we are having negative sign, so it is minus. This also minus. So it is x minus 15 into x minus 2 is equal to 0, which implies x is equal to 15 or x is equal to 2. And x is equal to 2 is not possible. Why? Because if pipe B takes only 2 minutes to fill the tank, then pipe A will be 5 minutes less than time taken by pipe B. So it will be 2 minus 5, minus 3 seconds you will, minus 3 minutes we will get for pipe A, which is not possible. So x is equal to 2 is not permissible. So our answer will be x is equal to 15 minutes. So pipe B takes 15 minutes to fill the tank individually. Is it clear, students? In the previous problem, type now. See in this question, pipe A can fill the tank 3 times faster than pipe B. Okay. So how much time it is not given to us, but pipe A can fill the tank 3 times faster than pipe B. So usually the students will think that if pipe B takes 10 minutes, pipe A takes 30 minutes. It is wrong actually. Okay. What is faster? The inflow of the water is more in pipe A than pipe B. Suppose if the tank is filled by pipe B in 3 hours, then time taken for the pipe A to fill the tank will be just 1 hour. That is the meaning of faster. Okay, it is quicker. Suppose if the pipe B takes 9 hours to fill the tank, then pipe A will take 1/3 of the time. That is 9 divided by 3. That is 3 hours to fill the tank. So we have to be very careful when we assume the time taken by pipe A and pipe B to fill the tank. So we start the solution. Let pipe B fill the tank in 3x hours. Okay. Why we are taking this as 3x, multiple of 3? Because for pipe A, the time will be 1/3 of the time taken by pipe B. It will be x hours. Is it clear? So part of the tank filled by pipe B in 1 hour will be 1 by 3x. Part of the tank filled by pipe A in 1 hour will be 1 by x, because it takes x hours to fill the tank. So in 1 hour it will fill only 1 by x part, 1 by x part. Okay, this is 1 by 3x part. Now part of the tank filled by both pipe A and pipe B will be equal to 1 by 3x plus 1 by x. And we take LCM now. LCM will be 3x. We solve this problem. We assume time taken by pipe B to fill the tank to be 3x minutes. Okay, why we are taking the time in minutes? Because we have here 36 minutes and we are taking the time to be the multiple of 3. Since time taken by pipe A to fill the tank will be 1 by 3rd of the time taken by pipe B. That's why we are taking multiple of 3. So it will be equal to x minutes. Okay. Now part of the tank filled by pipe B will be equal to 1 by 3x part. Part of the tank filled by pipe A will be equal to 1 by x part. Now both the pipes are operated together. So part of the tank filled by pipe A and pipe B will be equal to, because both are operated together and both are going to fill the tank, we are going to find the sum, 1 by 3x plus 1 by x. We take LCM for 3x and x. For 3x and x, the LCM will be 3x. So in the numerator, here we are having 3x in the denominator, here also in the 3x. So 3x will go in 3x in one time, so it is 1. And for this part, here we are having x, here it is 3x. So we multiply 3 in the numerator and denominator. So we get 3 as the thing. So this is 4 by 3x part. So in 1 minute, 4 by 3x part of the tank will be filled in. Now time taken to fill the tank by both the pipes is given by the reciprocal of the above expression. 4 by 3x is taken reciprocal. So it will be 3x by 4. And in the question, the value is given to be 36 minutes. Which implies x is equal to 36 into 4 divided by 3. So we cancel the term. So x is equal to 48 minutes. So pipe A take 48 minutes to fill the tank alone.